Good morning to all. Today we are discussing about Unit 4 Unsymmetrical Fault Analysis. Power System Analysis Steady State Dynamic. Steady State Network Normal, Network Faulted. Network Normal means balanced, unbalanced. Network Faulted, balanced, unbalanced. First one is a system assumed linear. Second one is a instantaneous photograph time. Then algebra equation. Then dynamic, network normal, network faulted. The first one, network balanced or unbalanced. Second, system linear or non-linear. Third one, solution in time domain. Differential equation. Effect of faults on power system. Flow of excessive current, abnormal voltages, voltage evaluation of system neutral, induced over voltages on neighboring equipments, hazards to human equipment and animals. Need for fault analysis. Design of production system requires the knowledge of fault current. The information obtained from the fault studies are used. First one, select the size of circuit breaker. Second one, fuse and its characteristics. Third one, setting of protective relay. Types of asymmetrical fault are: first one is a single line to ground fault, LG fault. Then next one, line to line fault, LL fault. Then double line to ground fault, LLG fault. And symmetrical component of power system. The normal operating conditions of an electric power system are occasionally distributed because of faults. Analysis of power system usually implies the computation of network voltages and current under a given set of conditions. Under many circumstances, we tend to ignore the unbalanced operation in the system, and unbalanced operation is always present. Need for symmetrical component analysis. Negative sequence relay in generator helps in protecting the generator from overheating in event of unbalanced loads. The positive sequence segregating network is used to supply the sensing voltage to generator voltage regulators. Then last one, certain connections of CT and PT develop zero sequence components that are used in protective ground relaying scheme. Phases are A operator. The phases notation of A operator, A is equal to 1 phase angle 20 degree, 120 degree, that is equal to J 2 pi 3. Then phase sequence component A 1 2, that means A squared. The phase sequence in the component of each phase displacement in 120 degree. A square is equal to 1 minus 120 degree. A cube is equal to 1 0 angle. Then A power 4 is equal to A power 5 is equal to A squared, A power 6 is equal to 1, etc. A function and polar and rectangular coordinates. A phase angle 120 degree minus 0.5 plus J 0.866. A squared 1 phase angle 240 minus 0.5 minus J 0.866. A power 3 1 phase angle 0 1 plus J 0. A power 4 1 phase angle 120 minus 0.5 plus J 0.866. 1 plus A is equal to A square is equal to, that is 1 phase angle 60 0.5 plus J 0.866. Then A plus A squared, that is equal to minus A. Then phase angle 1 phase angle minus 60, then 0.5 minus 0.866. 1 minus A root 3 phase angle minus 30, 1.5 minus J 0.866. Then 1 minus A squared is equal to root 3 phase angle 30 degree, 1.5 plus J 0.866. Then A minus 1 root 3 phase angle 150 minus 1.5 plus J 0.866. A squared minus 1 root 3 phase angle minus 150 minus 1.5 minus j 0.866. A minus a square root 3 angle 90 degree 0.0 plus j 1.732. And a squared minus a is equal to root 3 angle minus 90 0.0 minus j 1.732. Then a plus a squared and 1 phase angle 180 minus 1 plus j 0. 1 plus a squared, polar 0, rectangular 0. The positive sequence common set consisting of three components of equal magnitude displayed by 120 degree and 240 degree respectively, having the phase sequence of ABCA same as that of original phasors. The negative sequence set consisting of three components of equal magnitude displayed by 240 degree and 120 degree respectively, having phase sequence ACBA opposite to that original phasor. The zero sequence set of component of which being equal both in magnitude and phase. Positive sequence VA1, VB1, VC1. Negative sequence component VA2, VB2, VC2. Zero sequence component VA0, VB0, VC0. Then VA, VB, VC, that is equal to matrix 3 into 3, 1, 1, 1, 1, A squared A, 1, A squared, then VA0, VA1, VA2. A symmetrical component of generator in the sequence of in star connected generated A, B, C. Then phase current value, phase current is equal to IL is equal to IB. Phase current is equal to line current. Then phase voltage is equal to line voltage divided by root 3. Then EA is a IA current value. EB is a generator voltage. EC is a generator voltage. That is called line voltage. Sequence networks of synchronous generator. A positive sequence current path in the first one is a positive sequence current path in the star connection. Then reference bus, then EA is a generated voltage and Z1 is the positive sequence in the network voltage. V is equal to 1. Then IA1 is the current component. Then next one, negative sequence current path in star connected. IA2 is the current component of the value in negative sequence. Then Z2 is the impedance of the negative sequence. Then next one is a zero sequence component. It will be connected to the zero sequence in star connected. In the 3Zn is the total impedance value of the phase sequence in zero sequence component. 3In is equal to Ia0 plus Ib0 plus Ic0. Zero sequence networks of transformer. First one is a symbol, that means star to star, the sequence of the zero sequence circuit. Then second one is a star neutralized, then P and Q, and P and Q 0, Z impedance 0. Then next one is a star to delta, then Z0 and reference. Then star to delta again, then P impedance 0 Q, then delta to delta, then Z0 reference bus. Next, single line to ground fault. The most common type of faults is a single line to ground fault ABC. That is a fault impedance of the IA. That is impedance, fault impedance ZF. Then supply voltage VA, VB, VC, and fault current IA. Then another current value IB is equal to 0, IC is equal to 0. The sequence of component connection for single line to ground fault VA0 plus VA1 VA2. That is a zero sequence component in the 3ZF. That means fault impedance in the 3 phase. The sequence component connection of the single line to ground fault the sequence components are connected in series, the three currents in the case of SLG fault are equal. Thank you.